All right. Thanks everyone for joining this morning. We'll try and get started and get you in and informed and then out of here as quickly as possible. Um, Thanks for taking the time to listen today. This is the final webinar in a four-webinar series of building a defensible architecture. And the goal that we have here is to help walk through some of the concepts behind the SANS 5 critical security things and talk about what we consider the different vectors of north, south, east, and west that need to be prevented to actually build that defensible architecture. And I'll show a slide later on which kind of summarizes what we've talked about so far. But this particular webinar is focused on uh, remote access for third-party remote vendors, the supply chain, and we're going to talk a little bit even about what we're seeing in the AI agent space. So we'll save that one for the end, but it is an emerging and interesting development that comes along that we're seeing more and more asked by customers. If you have any questions, feel free to put them in the question pane, and I will either address them kind of in the flow of the presentation or come back at the end and get all of them. All right, so let's jump into this. If, by the way, anyone wants information on this, feel free to email me. My email is cam@blastwave.com. Okay. The first thing to accept is that the air gap is kind of permanently broken. Remote maintenance is very common in OT now, and it's almost a mandatory requirement in many scenarios, especially as some of the OT systems become, I'll call it more maintenance heavy and software updated by the manufacturers. This particular chart just shows a number of different research firms that have percentages of what percentage of OT requires remote maintenance or has installed that today. And I actually think these numbers, which are all below 50%, are probably a little low. But you never know. There's many different industries that are considered part of OT. Some water facilities may not have that yet because they're still operating in the Stone Age. Many of these systems are many years old and have no network connection or even cybersecurity aspect to that. So it is possible, but it is becoming less and less common as things move forward. In fact, it's also not unusual in an OT environment to see shared passwords. One of our engineers, Joe Baxter, tells a story of how he walked in as a security compliance auditor for NERC and saw basically a white board with passwords put on it and sticky notes on people's desks saying, check the whiteboard for the passwords. So this is something that is not unusual. Obviously, from a security perspective, shared credentials are not a good thing, and writing passwords down leaves you open to many forms of social engineering, to say the least. The other thing to keep in mind as we talk about remote access is that the global CVEs just continue to explode. And probably most troubling in this factor, it's not just the OT systems that are reporting CVEs, it's actually the firewall and VPN companies that are supposed to be protecting your OT network, especially remote access. Many of these systems have what I would call web-based vulnerabilities and CVEs where some of their web protocols can be exploited to cause the system to give root access or give administrator access or basically just totally bypass authentication. And it has just been continuing to skyrocket over the past few years. And even more concerning is it's actually being exploited much faster. It used to take 30 days back in 2020 for these things to be exploited regularly. Now we're seeing in just hours. In one of the other webinars earlier in the series, I talked about how they did a study with ChatGPT where if you fed some of the CVE descriptions into ChatGPT, it would tell you exactly how to exploit that from a code perspective and from an exploitation. So these things are now, once they get reported, if you are not agile, you are vulnerable. And this was made slightly worse. And basically, some of the predictions we've been making in this area became true when the Anthropic reported about how Claude was used by a Chinese nation state group to essentially attack networks. And this is the flow of that. If you're interested in it, we did a blog on it, but I also included the slide here. And what's interesting is the two things that I just talked about, the reconnaissance to determine what equipment you have and if the CVEs can be exploited, as well as the reconnaissance and stealing those passwords, are two of the major things that are accelerated and amplified by AI-powered systems and attacks. And the speed of these, if you go back to the previous slide around how they can do it in less than 24 hours, they also are sending thousands of attacks or requests a second. So if you have a detection system that you're relying on to stop an attack, it is going to be stressed heavily. And in fact, this is what's caused a lot of the fatigue alert that we're seeing in customers report. So if we take a step back now and say, well, let's look at this and how is that actually being translated into a weakness for OT security systems? And Clarity reported in a 2025 report that 80% of the initial access for attacks is due to poorly secured remote access, whether that's weak MFA implementations or passwords, exposed CVEs. So again, the two things we just talked about, 80% of the attacks generate from that. And I want to just give you some real world examples that have occurred, because at the end of the day, theoretical problems are not always worth spending your time on. But two of some of the most famous attacks in the world occurred using essentially third-party remote access credentials and as the way to get into the network. The Oldsmar water treatment plant attack in 2021, they had a TeamViewer account that was inactive. Suddenly, the account was logged into. Someone was essentially trying to open the water in this dam to cause it to start flooding the area. Fortunately, in this particular scenario, they actually happened to have an engineer who was on the system that was remote access into and saw what was happening where someone was trying to cause this trouble. So he was able to stop it in real time. But had he not physically been on that console, it would have succeeded. And it was because it was just, again, a weak password, no MFA implemented, and TeamViewer was open to the world. So this is something that we'll talk about how we can prevent this kind of attack. The other, and perhaps more infamous attack, isn't viewed of as an OT attack per se, but the irony is this is one of the few attacks where OT systems were the vector to get into the network. And this is the target, where an HVAC vendor had basically a credential stolen. They used it, the hackers used it to get into the network. They got into the HVAC system and actually laterally moved into the IT systems, stole credit cards, and essentially 40 million credit cards, cost Target over $300 million. And it was because they didn't secure the remote access into the maintenance system. So these have real world impacts. Fortunately, in the Oldsmar Dam scenario, they were stopped before it became a problem. But these are just two examples. And you will see we're doing a lot more of the highlights of these different attacks and how they occurred. So that's something to look forward for in the new year. So let's pivot to now, how can we prevent things like this from happening or prevent my network from being exposed or vulnerable to these attacks? And when you start putting together a secure remote access solution for third-party vendors, a couple of things to think about. One, it sounds a little strange, but should location matter? And if I see someone logging in from China to manage my PLC in New Hampshire, that's probably not an authorized connection. So being able to understand where people are coming from and restrict that is important from a secure remote access perspective. What protocols should I allow over those remote access connections? And we'll talk a lot about this one because it's important, because I think there's some misconceptions about what different security solutions provide and prevent in these scenarios. Do I need to, or can I prevent east-west movement by my secure remote access maintenance users who come into the network, maybe not only from remote access, but from another vector, which I'll talk about in just a second. And third, or fourth, is really, does the device that the user is coming in from matter? And how do I do MFA in this scenario to make sure that it is actually the person that I want to allow in? And what happens if that person leaves the company or they leave the maintenance provider? How can I ensure that they don't get access essentially to my system when they're not supposed to? So let's talk about some of the challenges here. And one challenge that is not often talked about when it comes to maintenance remote access is what happens if this remote access user, the third party maintenance vendor, is physically on site and sticks a USB key into a remote access system, into a PLC or an OT system. Can you prevent that maintenance user from doing bad things? So that's another aspect which is still part of the remote access security problem, even though it may not be a remote access, it is a maintenance security problem. So we do want to address that with some of the discussions that we'll have around here. So I mentioned the problems that I guess in the four different vectors that we talked about in the series. We talked about north for reconnaissance and what we do with network cloaking. We talked about employee remote access from the basically attacks out from the west side of the house. We talked about segmentation and lateral movement and threat vectors from the inside, where people are trying to move east-west that they're not supposed to. And today, what we're essentially talking about is on the south, which is you have maintenance users who are actually getting into the devices or getting into the devices from remote, and what can they do from that perspective? So if you can control all four of these directions of attack, it gives you the ability to make sure that you have a 360-degree protection of your network. So let's talk about how we can do that. And we do that essentially with BlastWave with our secure remote access. What I'm going to do is walk you through a little bit of how our secure remote access users are set up, so you can see just how easy it is to get set up, and the security of that registration process. And when a user logs in, how difficult that would be to mimic, hack, or social engineer or use AI to stop them. So the most important part of this process is the invitation you get from the user. In the orchestrator, you configure a user. you start that process, say, I'm going to allow this user, and I'm going to create an invitation for him. Now, anytime you want to add someone to remote access, you have to do this in any system, whether it's a firewall, whether it's a VPN. You know, typically in these things, you send them their email and their password in an email. Well, what we do with Blast Shield is you get a link. This happens to be shown that registration link happening over Slack. It could be any other messaging system. You can copy it and download it and email it to them as well. But it is a physical invitation that the moment they click on this, it registers their authentication device with the system. And what happens is then it pops up and asks this user, how are you going to authenticate to the network? And most of the users of our solution use our mobile app, which is what I'll focus on. But we do support things like FIDO keys, which in the maintenance scenario might be very important for the maintenance contractor to have a few FIDO keys, which are the backup in case someone leaves or the mobile phone dies or they need access to something during emergency hours. We can support FIDO keys, or if the enterprise is using SSO, you can also use SSO with the caveat you're now opening yourself up to password and phishing and all the other attacks as well. So I want to talk about the mobile application itself. So with that mobile app, after you click on that you want to authenticate, what it will do is it'll present a QR code. If you don't have an authenticator app, it shows you how to download that. But when you scan this with your phone, what it does is it create a public-private key saying that I know now as the Blast Shield orchestrator, basically the public key that you're presenting from that device. And now every time you go to authenticate yourself, your possession of that device and your ability to authenticate with that device and pass biometric authentication, whether that's face ID, whether it's your thumbprint or biometrics. What we've now done is say that I don't care what physical system you have the client installed in, whether it's your laptop or whatever, but I'm tying your authentication to that mobile device, or so you can be authenticated with a device, a biometrics, the fact that you have the Blast Shield client and you're configured in the network, and that gives you access to the Blast Shield or the overlay that you are permitted to access as a third party. And what's interesting about the solution, there are no passwords to steal with this mobile authentication. So you can't be phished. You receive an email saying you need to change your password. You know it's fake because there are no passwords. Everyone has their mobile device with them, so it's something you have. You don't have to remember the password. You don't have to write it down. So it does provide a very convenient thing, and it uses the same technology as Apple Pay and Google Wallet to authenticate and secure that. Even if your laptop is hacked, they still can't get in because you need the mobile device. If they hack your laptop and your mobile device, they still can't get in because your device certificate is kept in a separate OS protected space inside the system, and you still can't get access to that certificate that's in there. So it does provide a much higher level of security to users and not allow you to be attacked. And then what we present you with are two options. So I mentioned privileged access management systems and remote desktop in the Oldsmar case with TeamViewer. The way we provide both options is, first, when you launch that Blast Shield client, you now have a connectivity for interactive remote access. So in this case, you now have interactive remote access as an individual user, depending on what your permissions are. So let's say, for example, that you have this safety contractor down here. As you can see from the blue line, he is only allowed to talk to the safety devices. A control and maintenance contractor can talk to the control zones, and a process maintenance can only talk to the process. So you have restrictions. They can talk whatever protocols you configure. They use real applications on their laptops. If you have a PLC, an HMI, where you're controlling the systems, that can all run in full interactive from the user's laptop itself. The second option to this is we have a new product called Blast Access, which runs a secure remote desktop solution over the Blast Shield client. So again, we still have all that authentication, all the passwordless MFA, phishing resistance, but we're now saying, rather than getting full interactive remote access, we're going to basically allow you to connect to this Blast Access remote desktop server. And now with this remote desktop server, you can do the common things that you would do in an RDP solution. You can upload files, you can click on whatever applications are on that server. And now what it is every one of these maintenance users is given access just to this jump server that sits inside the DMZ or somewhere in the OT environment. And then from that jump server with the Blast Access, it controls, determine that safety can only go to the safety systems. The maintenance can only go to control. So the Blast Access becomes the server where you're actually not running an interactive desktop, but I'm running a remote desktop where I'm now clicking around on that screen and do that. So it provides, if you don't trust laptops or you don't trust the systems that they're coming in and you don't want them to have full interactive access, and this allows with Blast Access you to limit that. So it is a further narrowing of the scope that your remote maintenance contractors can do. And we will be adding session recording to that, which is a requirement in some markets. So I saved something interesting to talk about for a few minutes here about AI and cloud. So we're definitely seeing that more customers are interested in integrating into the cloud and into AI. We're actually a partner with Inductive Automation, which has a cloud-based SCADA system. We've had a lot of customers talk about using Gen AI to learn. And in some cases, they're not yet using it to control, but they want to pop up data into their historians there, have the Gen AI system study what's going on and determine if there are ways they can improve that. So that's not necessarily remote access. However, I don't want any Gen AI system to have unfettered access into my OT network and to send commands and to do things. So we can install a cloud agent in front of that essentially Gen AI cluster that sits out in the cloud to make sure that no one can get into those systems from the outside and cause my Gen AI system to go rogue or begin doing bad things. But I can also use it to control what protocols and messages are allowed to come into and out of that network. So I may, for example, say that the Gen AI system is only allowed to ingest data coming from my OT environment as a one-way pipe, similar to what you might use with a data diode, to make sure that the Gen AI system can't suddenly start trying to control it, or if it's taken over by someone, start sending JSON or Python or some other API to cause my systems to blow up or to start doing bad things. So it is a way to get a foot in the door. And if you want to start allowing the Gen AI systems to control or interact, you can let specific protocols, only just specific machines or specific devices. So it is a way to kind of dip your toe in the water for AI and the cloud and OT environments, but not yet give full access. And I wanted to finish this off by giving an example of a customer of ours that's using our solution in exactly this use case that we're talking about. And it's Lineage, which is a cold storage chain where they basically think of them as refrigerators storing food. And they came to us with an interesting challenge. And what Lineage had been doing is they're a manufacturer. They were looking for a new secure remote access solution, and they had been acquiring companies along the way to add to their footprint. As many companies do now, they want to buy more assets. They want to grow the size of this. And what happened with them is they acquired bunches of these assets, and as a result, they had essentially a mishmash of secure solutions throughout their environment. One had one firewall brand, another one had a different VPN, and one of their maintenance contractors was hacked, and a hacker gained access to the network and it basically messed up 26 of their sites. And with someone like this, it's actually very dangerous because their refrigeration systems can basically turn into bombs if they are manipulated in bad ways. If you're familiar with what happened to Lebanon, the ammonium nitrate explosion they had in their ports. So this bunch of different security solutions caused them to realize they had really a huge attack surface and very little ability to stop attacks because they didn't even know necessarily which system was at each site. And they had to install these in places where they didn't really have IT. These were just little warehouses. They didn't want to send someone out every time they had an issue. So with BlastWave, what they did is, and I have little diagrams here, you can actually see this is the only part of the refrigeration unit that is protected. So they have their data closet, and they put, basically Blast Shield. This is the Blast Shield device here, plugged it into the network. All the local guy did was basically plug one port into the WAN and one part into the LAN, and that's all they had to do and power it on, and then it could be configured and managed from a central location. We actually have QR codes or barcodes on that the local person takes a picture of. The administrator uses that to configure that device remotely using that MAC address that's on the sticker. Now they can cloak and segment that local network as well as grant maintenance contractors very specific access into only the devices that they need access to. There's no phishing capability. So essentially, what they've started doing is recommending all of their maintenance contractors use our system for other customers as well, because it's secure and actually removes liability from the maintenance contractor as well. So they're deployed across 7 countries and 241 sites with this very use case. So it's a good proof point, and they haven't been obviously hacked since they've used our system in the network. And so the goal of what we're trying to do is prevent these industrial cyber attacks, in this particular case by blocking off that particular vector. So if anyone has questions, feel free to put them in the question pane. Looks like I have a queue. A few are already in here I'll address while anyone thinks of the ones that I have. One of them is, can you integrate this remote access with other firewalls or VPNs in the network for segmentation? The answer is yes, but it probably doesn't really exploit the power of BlastWave. And if you have a firewall at that site, there's really no need for it. If you put the BlastWave into remote access, our segmentation is all software defined, which if you go back and watch the segmentation webinar and the cloaking webinar we did, we'll give you a lot more information on that. But you start to lose the device level segmentation and granularity for least privilege access. And you start authenticating people and just putting them to a subnet, which has access to all the devices on that subnet. So you lose especially the ability to prevent east-west movement inside the networks. It says you mentioned RDP. Do you mean privilege access management solutions? Aren't these secure enough for OT? And this question is actually tied a little bit to the previous one. Yes, a PAM solution is designed for remote access. A couple of the issues with PAM is typically they are based on web browsers. And using a web browser as your only authentication mechanism and your only pipe into the network without something like the Blast Shield passwordless MFA client, we've seen so many cases where things like password vaults or web hacks basically make the system that the user's on liable to sniffing, to control, basically keystroke monitoring. So those web-based solutions typically get you in a lot of trouble. And once you have them, they can be manipulated with man in the middle and other attacks. So a PAM is a competitive solution in this space, but it doesn't do the same level of security that a Blast Shield system or a Blast Shield plus Blast Access gives you in terms of protecting the credentials that are coming in, as well as not letting attacks through with that open port, which often happens on the RDP side. And the last question that seems to be popped up is about the AI, about the Claude and Anthropic attack. Is it really a threat or an issue for OT networks? And the answer is, yeah, it really is an issue. You are seeing more and more cases where the ability of these systems to automatically exploit known CVEs and to create mass phishing emails. And remember, in a Gen AI phishing campaign, all they need is for one person to click. And if that person happens to be an administrator, you're doomed. So it is a problem. The more you block those AI-powered vectors of reconnaissance and phishing, the more likely you will be to have a secure network. And frankly, if your network resists those two vectors off the top, you're probably going to get skipped, because a lot of these hacking groups, if they're not nation states and are really trying to get in, they're criminal enterprises, and they're not going to waste time on someone that has hard to get into. They're going to take the guys that are easy to get into and hack them instead. So looks like that's all the questions. Thank you for your attention. And again, there are 4 webinars. If you missed any of these 4, we're going to send an email out just to give you the links to the replays of all of them. But thanks for your time today, and have a good rest of the day, and have happy holidays. Thank you.